Okay, guys, everybody should have drawn this in your notebook. So we have a diver at the top of a cliff. She's looking down at the rocks, and she has to look at an angle of declination. This is horizontal. This is if you were looking horizontally. She has to look down 75 degrees to see the edge of the rocks. What's this angle in here? This is 15. It's the rest of that 90 degrees. We call that a complement, right? This is 15 degrees. And we're interested in this particular triangle right here. This is more or less a right triangle. This side is the height of the cliff plus the level to her eye level. Y'all see this is 55 over here? Everybody see that? And we need to know how far out do the rocks reach, because this is the safe zone where she can dive into the water, but we need to know how far out the rocks go. Now, she suspects that she can go more than 12 feet. So if the rocks are less than 12 feet, she's probably okay. But we need to figure out this problem. Now, when we were doing the shadows, we had an angle to the sun, and we were able to come up with proportional triangles because the sun angle was the same. Now, yesterday, when we did our problem, what we did was we drew another triangle, a right triangle of 35 degrees for our to solve our problem. Today, if we wanted to, we could draw a 15-degree triangle and use it. But we don't have to draw it, because what you guys did is you made your own triangles, right, in your trig book. So you have that triangle already drawn. And that's what we're going to do. We're going to set up our triangle, and your triangle looked like this in your trig book. So what you did was you have 5, 10, 15, 20-degree triangles, and one of them is 15 degrees. So this is 15 degrees, and this is a 15-degree right triangle. So what I can do is I can use the sides of this triangle that I know, because I found what the sides are, I measured them, and I can use them to solve what's missing from this triangle. So we're going to set up a proportion. This is a 15, this is my angle, it's called my reference angle right here. Yeah. This is my reference angle, and this side is across from it. So we call this the opposite side. And that's our what we're interested in solving for. We want to find this opposite side, and we know this side. What's this side over here, by the way? But what's this side over here, though? What's it called? It's the hypotenuse, that's right. On a right triangle, the hypotenuse is always the longest side, and it's always across from the right angle. We always call this the hypotenuse. They call this the opposite leg because it's across from the angle. See that? And we call this one the adjacent leg because it's next to it. We usually just put ADJ and OPP and HYP. We always, just put hypotenuse for this, OPP for this one, and the ADJ for this one. Hey, what's up, Danny? Forget something?
Can I see my booklet and the hammers?
Oh, yeah, of course. Go ahead. It's in that pile in the period. Which period are you in? Okay, guys, so what we're going to do is we're going to set this up. Which two sides are we interested in? Yeah, go ahead.
The hypotenuse and the adjacent.
Not the hypotenuse. Opposite is the rocks, isn't it?
Yeah.
And the adjacent is the thing we know. So I'm going to set it up. Opposite over the adjacent. And I'm just going to write my proportion. R over the adjacent, which is the 55. And if I had another triangle that's similar to this one, I would be able to set up my sides. And I do, because you guys drew them yesterday, I have a 15-degree right triangle. What side is this? This is the opposite side. And this side? Hypotenuse. And this side is the adjacent. So what I'm going to do is I am going to set up my proportion using these numbers. Now, your numbers are going to be slightly different than mine, but what's going to be the same is the fraction. Your fraction is going to be equal to mine. So when you write your numbers, it will be the same, but it's okay. I'm going to use this one. I'm going to use the 5.0 and the 18.75. Yeah, of course. Now, the thing is that when we do this, we could just change it to a decimal, and that way everybody's looks the same, right? Yep. So let me get the decimal for mine. Let's see how close I was. I'm going to divide 5 by 18.75. And I get, oh, I didn't get the decimal. I get 0.26 or approximately 0.27. See what you guys get for yours. For those of you who have your triangle drawn,
What number is
so let me show you. I'm going to take opposite over adjacent, which is 5 over 18.75. You got about 0.28? That's really good. Yeah, 0.28. Mm-hmm. Now, how am I going to solve this for the R? You just divide it. What were your numbers?
Oh, 4.05.
4.05 divided by? 0.26. About 0.26, right? Did anybody else get theirs? If you divide your sides, you should get about the same decimal that I got. Now, how are we going to get the answer to our equation here? R over 55 equals this. I got to get rid of the 55. How do I do that? Just multiply. You could put it over 1, right, and cross multiply, or just multiply by 55 on both sides. Whatever makes more sense to you. You don't want to cross multiply this one because everybody's is going to be different. Yeah. But it's better to just use the decimal. This cancels out, and we get R is approximately about 14. 14 what? Nope. Yeah, feet. So what do you think? Should she dive?
No.
Oh, no. That is not a good plan. This is about 14 feet. Now, she knows she can make the 12. And if she runs, she might make the 14, but she might not, too. That is not a good plan. Everybody clear? How it works?
Yeah.
What we did was we used a triangle that's similar to this one to solve it. Now, it just so happens that these decimals are all in your calculator. All of these numbers have a specific value out to like 8 decimal places, and they're all in your calculator, and we can look them up. But I wanted you to see where they come from. Kind of like when you guys were calculating pi, remember when you divided the circumference by the diameter? And you got about 3.15, 3.16, whatever. It's like that for these. There is a number for these, but we want to get an approximation. Now, I decided to teach this because yesterday was parent conferences, and I had a young man yesterday that had a very close to a 70%. He was like right on the 70% mark. And I had a problem with that, and because he was perfectly okay with getting a D-. He was like, oh, I'm getting a D-, that's great. So what I wanted to do today is I want to do a little proportion problem for you. And what I'd like you to do is set up the proportion for 22 minutes. I kind of estimated that he spends about half the period or a little less than half the period working. So if 22 minutes gets him a 70, what does he have to do to get an A? How much more work does he have to do? So let's do the proportion here. Let's see. 22 minutes
We do this in our notebook.
gets a 70, yeah. So let's assume that 22 minutes gets a 70%, and we want to know how many minutes does he have to work in order to get his A. What's an A?
80%.
90 or over. Okay. So let's see if it's worth it. Let's see. Cross multiply.
If you just work the whole time, then you'll get an A.
Well, there's that. But let's just do let's cross multiply here. 90 times the 22. 1980. And then what do we do? Divide by the 70. And we get x equals about what?
28.
Approximately 28 what? Minutes. Oh. So how much additional work would he have to do in order to get the A?
6 minutes.
Instead of a D minus? Does that sound right? Doesn't that sound wrong somehow? I mean, it intuitively, if it takes this much work to get a D minus, doesn't it seem like it would take a whole lot more work to get an A?
Yeah.
Doesn't that sound right?
Yep. No.
Okay. So I have a story to go with this. I always seem to have a story for you. The thing about this story is that it's a true one, and I'm going to tell you why this is actually correct. And I'm going to show you the difference that 6 minutes makes. So I have a story about two guys. I know both of them. And in fact, I'm going to show you a picture of one of them. I don't have a picture of Carlos, but I do have a picture of Hector. Now, Hector and Carlos, in about 1978, both started at Kiki's restaurant. Now, they both started working dishwashing. Carlos and Hector both were dishwashing. Hector was a bit older than Carlos. Carlos had just graduated from high school, and his mom was a cook at Kiki's restaurant. This is a true story, guys. Now, Hector went to 8th grade, and he was quite a bit older. He was probably 30 at the time. Now, he only had an 8th grade education because he had to go to work to support his family. Now, he was washing dishes, but here's the difference between those two. The difference was Hector could be absolutely depended upon to be on time. He was a dishwasher, but my partner Paula, she knew he was going to be there. Every single time he said he was going to be there, he was there. He was right on time every single time, maybe a minute or two early. On the other hand, Carlos, not so much. He would sometimes get there a few minutes late. Sometimes he wouldn't show up at all. Now, fast forward 20 years. Hector was the manager of the restaurant, making $160,000 a year. Guess where Carlos was?
His dishwasher.
He was still washing dishes. 6 minutes of difference. 6 minutes. Think about that. Carlos would show up a few minutes late. Sometimes he wouldn't show up at all, but most of the time he would be there. And he mostly did what he was supposed to do. And he's kind of a D-minus worker, isn't he? But Hector could be absolutely depended upon. So the rest of the story is 10 years ago, or about 8 years ago, Paula sold the restaurant to Hector for $1 million. He paid it off in 3 years. It's already paid off. He owns $1 million restaurant. He makes about $300,000 a year. Now, 8th grade education. Now, this is Kiki's restaurant. This is the restaurant I'm talking about. It's wonderful. That's Hector. He now owns Kiki's restaurant. My girlfriend owned it for 35 years. Now Hector owns it. And he is he's going to be a multimillionaire. And the reason is because he does just a little more than you absolutely have to. And that's the key. You see, most people will do what they absolutely have to do and no more. They just go to that edge of just to the edge of what they have to get done, and then they stop. But there are a rare few individuals who go just a little past that, maybe 10% more. And they are amazingly successful because they have discipline to do more than what they're told. They don't have to be told. Hector, he doesn't have to be told to go to work. He goes to work every day, day in, day out. Dependable. So I hope you guys will take that to heart and actually do more than what's absolutely required, because that's how you become successful. So what we're going to do today, you guys are going to, let me get this. There we go. You're going to mark up your triangles, and we're going to identify the opposite side, the adjacent leg, and the hypotenuse on all of them. And there's names for these things. You guys know the names? There's names for the sides of the triangle, the proportions. This is how you remember them. How many of you have ever heard this before? SOHCAHTOA. Have you heard it before? Okay, it's a mnemonic device. It's a way to remember. Sine, this is the first one, is opposite over hypotenuse. It has a name. Yep. This is, by the way, this is 5 degrees. I'm doing the 5-degree one. Cosine.
You have to do this for all of them?
Yeah. Now, cosine is, take a guess.
Hypotenuse.
What's the A? Cosine is the C.
Angle.
A is adjacent over hypotenuse.
I'm on that. Come on. What? Total?
And this one is tangent. Tangent
Over opposite.
is opposite over adjacent. Yep.
But you yes.
Now, what I'm going to do is each one of these, I'm going to just write my numbers. Now, you guys are going to have different numbers than me, but mine are 1.5 over 19.1. Adjacent over hypotenuse is 19 over 19.1. Now, yours are going to be different, remember? And my opposite over adjacent is 1.5 over 19.0. And what I'm going to do is I'm going to get decimals for these. Now, I'm going to round mine to the nearest hundredth. You guys will probably get pretty close to the same as mine. It won't be exact because we're not very careful with our triangles might not be perfect, but 1.5 divided by 19.1, I got 0.08 approximately. See what you guys get for yours. Thanks, Daniel. .99 for this one.
Wait, so what am I supposed to do? Oh, wait, how much?
I'm just dividing 1.5 divided by 19. 0.08 again. Now, you may not get the exact same numbers I get, but that's okay. As long as you're reasonably close. Now, I'm going to show you something. For my sine of 10 degrees, I got 0.17. This is the actual value. Pretty close. 0.1736. I was very close. This one was 0.99, and the actual value is 0.9848. And this one, I got 0.17, and the actual value was about 0.17, 0.17. So you guys are going to write your sine, cosine, and tangent. Now, what I recommend you do is when you're writing them, don't copy it. Actually write it from memory. So like when you do these, like this, don't look at it. Do sine of 25 is, what's the sign? Sine? Opposite over hypotenuse. Cosine? Adjacent over hypotenuse. And tangent. Opposite over adjacent. Now, I did not learn SOHCAHTOA. That was unfortunately after I'd already been teaching for a while. I learned, this is stupid, it was 40 years ago, and I still remember it. Otto had a heap of apples. I have no idea why that works, but I remembered it for 40 years, so I guess it works.
What?
Otto had a heap of apples. It doesn't even have the C's and the S and the T in it, but I always memorized it, sine, cosine, tangent in order, so there it is. Otto had a heap of apples. I don't know why that worked for me, but it did. Okay, guys, write yours out. You're just going to estimate your values. Now, those of you who were here yesterday, remember when I showed you how to draw your triangles? For those of you who want to redo it, Eric came up with a much better technique than mine. You know how I always started with my angle and then I drew my right angle? I'm so dumb. Look, Eric showed me, watch how easy this is. If you draw your side first, like be real careful, draw your side first, and then draw your right angle, and then draw your angle, it's so much better, right? And then just measure your angle, and I can't remember what this one is. Let me see where I'm at. I'm on, let me see. So for my trig book, I'm on 25 degrees. So this one is supposed to be 25. So I'm going to draw my 25-degree triangle here. Watch this. So I drew my right angle, right? Watch. I don't know why I didn't do this before, but here we go, 25. All I have to do is measure it, and no estimating, no guessing. There's my 25. Duh. Oh, didn't work. I didn't draw it far enough down. Well, it's okay. The thing is that I didn't think it through enough, but I should have went further down. But anyway, I'm going to go with 20 degrees so I can fit it. And I'll put my 25 on the top. By the way, I could have just gone over here, couldn't I?
Are you recording?
Yeah. I could have gone here. In fact, okay, so for 25, I could just go to here. And that's going to fit for sure. And there we go, 25. Barely, but it makes it. There we go. There it is. And so there's my 25. And it's about as big as you can make it. It happens to be 15.4. Hmm. 16.9. And almost exactly 7, maybe, yep, 7.0. Now, what's nice is the units don't matter so long as they're all the same, because it's all about the numbers themselves. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Yeah, that's it.